Hello, my dear. I welcome you in this session of PYQ of thermodynamics. I hope you are all good and your preparation going to be in a right direction. I am Pragyabrat Tripathi, Faculty Department of Mechanical Engineering. So, my dear, today we will discuss of the PYQ of thermodynamics of 2020. Okay. So, please confirm me or the video, audio, everything is clear. Okay. So, my dear, just okay. So, yes. So, today we will discuss the PYQ of 2020. So, first question, it is the question related to the psychometric, that means properties of air. Okay, beta. See, my dear, in the refrigeration and air conditioning, there are two topics. First is the refrigeration system. That means there is a refrigeration, and second one is the air conditioning. So, in the case of air conditioning, we have to study the properties of the air. And in the property of the air, the branch of that property of air which we have to study is that is called psychometric. So, the first question is related to the psychometric. What is that? I will read the question. What is that? A moist air. That means this moist air, that means the air, normal air. That means what is the air which is present in the surrounding? Moist air at a pressure of 105 kilopascal and its temperature, that means the air temperature, it is given 30 degrees centigrade, and its relative humidity, that means air it is in the surrounding is there, and there may be a relative humidity, and that is your 80%. Okay, flows over, that means it is flowing over a cooling coil. So, there is an arrangement of a cooling coil which is try to cool the air. That means this air is passed through a duct. In a duct, there is a cooling coil, and that cooling coil is cool this moist air. Cool this moist air. Okay, and this cooling coil, that means it is a duct, and the duct is insulated. Okay. Saturated air, that means now this is the entry point, this is inlet to the duct. Now the exit, what is the exit from the duct? The duct exit at a saturated liquid. So, this is a moist air which is unsaturated, and it will enter, it will exit from the duct, and that duct, it is your moist duct, it is your unsaturated air. That means unsaturated air into the duct, and saturated air will exit from the duct. Okay, so when it is exit, its pressure is 100 kilopascal and temperature is 15 degrees centigrade. That means obviously its temperature will reduce. Why? We have to cool the air. Okay, the saturation process of water, the saturation pressure of water at 30 degrees centigrade and 15 degrees centigrade, it is given. What is that? At a 30 degree, the saturation pressure of water vapor, it is given 4.24 kilopascal, and saturation pressure of water vapor at a temperature 15 degree, it is given 1.7 kilopascal. Okay. Now, molecular weight of the water, it is given 18 gram per mole, and that of the air, we know that this, we have to already know that 28. Someone asks you, what is the molecular weight of the air? Molecular weight of the air, 28.94 gram per mole. Now, they are asking that, what is the asking? Mass of the water condensing. That means if there is a duct is there, and in duct there is a cooling coil is there. Now, air it is in, and the another property of the air which is exit, during that the air will condense. During that air will condense. Why? Because the cooling coil will extract a heat from the air. So, air will condense. So, what is the amount of condensing water? That means in the water there is a vapor is there. So, that vapor will condense. So, what is the amount of the vapor will condense? That means what is the mass of the water will condense out from the duct, and the asking is kilogram per kg of the dry air. That means gram per kg of dry air, and it is related to the NAT, numerical answer type question, NAT. Okay. So, my dear, what is your approach? Just think, what is your approach? How do they solve? See, my dear, if there is a duct is there, inside in the duct the air will exit. Air exit have some specific humidity, and air entry have some specific humidity. If you differentiate this two specific humidity, what is the value of that condensed water? That value is the your answer. That means if you just differentiate the specific humidity. Why? Because beta, specific humidity gives the information about the condensing of the water. Okay, so the question, it is related to only just you have to find the specific humidity at entry, specific humidity at exit, differentiate these two. What is the value? The value it is in your answer. Okay, so we have to try to solve this one. So we have to try solve this one very quickly. Okay, no problem at all. So my dear, yes, so this is your duct. Okay, this is your duct. One second, beta. This is your duct is there. This is your duct is there. Okay, this is your duct. Yes. Now the air it is in and air which is exit, and this is your cross section which is in and exit. This is your cross section, inlet cross section, and this is your exit cross section from the duct. In between that there is a cooling coil. In between that there is a cooling coil. So let's suppose this is your cooling coil. Okay, this is your cooling coil. Okay, no problem at all. This is your cooling coil. This is your cooling coil. Great. This is your cooling coil, which is cool the air in the air condition. This is your cooling coil, precisely. Now, the air which is enter at this point, this is your air at entry. The air which is enter here, this is entry, and the air which is exit, this is your exit. Okay, the air which is in, the air which is exit. Now this is your cooling coil. Okay, this is your cooling coil. Okay, this is your cooling coil. Now this is state point 1 at inlet. This is your state point 2 at exit. Great. Now this cooling coil extract a heat. This cooling coil extract a heat so that the air will cool. Extract a heat. So this is your heat. Okay. Now at this point, this is state point 1. Here moist air. What is that? Moist air. Moist air it is in, and this moist air have a property. It is given the temperature T1 inlet, specific humidity omega 1, and relative humidity phi 1. We have to define a property. Okay, and this is your exit, and exit is your cool saturated air. Okay, this is your cool saturated air. Okay, and here also this property it is given phi 1, phi 2, T1 temperature it is given. Let's suppose T2, omega 2, and phi 2. Okay. Now my dear, you know that for the saturated air, the relative humidity is 100%. That means phi is equal to 1. Why? Because this is your saturated air. So this relative humidity, it is equal to 1. That means 100%. Why? Because saturated air. Saturated air. Okay, we know that this thing. For the saturated air, relative humidity. Okay, how much it is? No, wrong. Papaji, wrong. It is wrong. Okay. So this is cool saturated air, this is okay. Now there is a temperature. Now it is all the value it is given. State point 1. State point 1. What is given value? We have to write a given value. What is that? Moist air. What is that? Moist air. Moist air. Moist air. Pressure P1 it is given. How much? 105 kilopascal. Kilopascal. Okay. Temperature it is given T1. 30 degrees centigrade. Okay. Relative humidity it is given 5.1. How much it is given? 80%. In the question 80% it is given. Okay. And also partial pressure of water vapor under the saturation condition at point 1. It is given how much? 4.24. Yes or not? Kilopascal. And this is given corresponding to 30 degrees centigrade. 30 degrees centigrade. Now, this is the state point 1. Now, from this state point 1, we have to easily calculate what is the value of omega 1, specific humidity. So, we know that for the specific humidity, what is the value formula? We know that the specific humidity omega 1, what is the value? What is the value beta? 0.622 into partial pressure of water vapor at point 1 divided by total pressure P minus, that means P1, partial pressure of water vapor under saturation condition at point 1. If you don't know this formula, you can never solve this problem. Okay, I will also check your comment also. Okay, yes. Okay, so now my dear, partial pressure of water vapor under saturation condition it is given. Now partial pressure of water vapor it is not given. Partial pressure of water vapor it is not given. So how to find this value? How to find this value? You have to find this value from the relative humidity, phi1. And we know that for the phi1, that means a relative humidity, to finding of this one, we know that the relative humidity phi is equal to partial pressure of water vapor divided by partial pressure of water vapor under saturation condition. So this is 0.1. So this is 1. This is 1. Now partial pressure of water vapor under saturation condition it is given. So and relative humidity it is given. So easily you have to find the partial pressure. Okay. PV is equal to MRT. Great. Papa is great. You have right here. Why? Because it is ideal gas equation. Correct. So from here, if you put this value 0.8 is equal to partial pressure of water vapor at point 1 divided by partial pressure of water vapor under saturation condition 4.24. So from this one, you have to easily find partial pressure of water vapor at state point 1. How much it is? Just tell me how much it is. It is your 3.392 kilopascal. Great. So this is your partial pressure of water vapor at the inlet condition, which is your moist air. That means this is a partial pressure vapor pressure. Yes, PV by PVS. Correct. 3.39. Correct. You give the reply very quickly. Okay. Now you have put the value here. PV. So find the value of omega 1. What is the specific humidity at point 1? Please find it. What is the specific humidity at point 1? Please find it. Put the value of PV1 3.392. Pressure it is given 105. PVS it is given 4.24. How much it is? Please find it. How much it is, beta? Please find it. Everyone please find it. How much it is? So if you find this value, this is your 0.02076. What is the unit of this relative humidity? Kg of water vapor per kg of dry air. So this is your unit is kg of water vapor per kg of dry air. Very important. This relative humidity, this specific humidity, it is not sure that, yes, 0.02, correct. Now, very good, Rahul, very good, very good. Now, please, how to find omega 2 at the exit condition? Rahul, you are right, beta. How to find omega 2 at exit condition? Please, I give you time, 1 minute. So, this is at state point 1. How to find the relative humidity at point 2? That means the relative humidity of saturated air. Please find it. Same. So, at state point 2, state 2 is what, beta? State 2 is what? Saturated air. Yes or not? Saturated air. And we know that for the saturated air, the relative humidity is 100%. We know that from the psychometric chart. Correct. So, again we have to phi PV divided by PVS. This is at point 2. This is 2. This is 2. This is 2. So, this is 1. So, what is your PV2 is the same as PV, partial pressure of water vapor under saturation condition at 2. And this value it is given at point 2, the value it is given P2, pressure is 100 kilopascal, okay. Temperature at exit, it is your 15 degree centigrade, okay, and PVS2, it is given 1.7 kilopascal, correct. So, here it is value is 1.7 kilopascal. So, this is your PV, partial pressure of water. How much it is? 3.39. No. Wrong. Okay. Mass of the vapor, it is mass of the vapor. That means this is your mass of the vapor, not mass of the air. Mass of the vapor and divided by mass of the air. Okay. This is the mass of the vapor divided by mass of the air. Now, what is omega 2 at this point? 0.6. What is the formula? 0.622 PVS at point 2 divided by P2 minus P. This is your PV2. This is your PV. This is your PV. And this is your not PV. This is your PV. Partial pressure of water vapor at point 2 minus partial pressure at point 2. Put all this value. That means 0.622 PV2 it is equal to 1.7. Total pressure is 100 minus 1.7. How much it is? Beta? It is your 0.01076. Correct? 0.011. It is your kg of water vapor divided by kg of dry air. Now you have to find, we have to find omega 1 and omega 2 successfully. Correct, Rahul? Correct. Very good. Now, then we have to find it. What is the amount of? That means we have to find the, what is the question? Question it is saying that the mass of water condensing. So, what is the mass of water condensing? The specific humidity at inlet minus specific humidity of outlet 0.1. Yes, the answer it is in gram per kg, beta. If you put, no, not energy balance. Not energy. If you balance the energy, same formula it is there. If you balance the energy, same formula it is there. Yes, it is the value. Directly you have to remember like that, ki if you find the specific humidity of a particular point, you find the specific humidity of another point, differentiate it. The difference, it is the condensed water. That's it. The difference, it is the condensed water. That's it. Okay. To find the energy balance, same formula will come. Okay. But it is little bit lengthy. Okay. So here omega 1 minus omega 2 is equal to, this is your mass of water, vapor which is condensed, water vapor condensing out from the duct, correct, out from the duct. So how much it is? How much omega 1? This is your 0.02076 minus this is your 0.010756. If you differentiate this one, this is your 0.010 kg of water vapor per kg of dry air. My dear, if you put the value of 0.01, your answer is wrong. Why? Because see the unit. The unit it is asking gram. So unit it is asking gram. So convert it into gram. So this is your kg. So gram it is your 10. So this is your 10 gram divided by per kg of dry air. That's it. This is your answer. Correct na? Correct. No, not 0.01. Not 0.01. Yes, this is your 10 gram. This is 0.01 na. This is 0.01 kg. Convert it in gram. 10 to the power minus 3. 10 to the power 3. So if you 10 to the power 3, so 3010. So 10 gram. Clear na? Yes, correct. 10 gram. Why? Because in this question they are asking gram. Be careful. This is asking in gram. It is in gram. Clear? This question is clear, beta? But this question is very easy. But if you don't know how to find the condensing water, if you apply the energy balance equation, you have in trap. Why? Because if you going to balance the energy, the answer a time consuming process. That is the time consuming process. So always remember that if you find the condensation quantity of in air conditioning, just you have to differentiate the specific humidity. That's it. Clear? That's it. Okay. Now we have to go to the next problem. Yes, this is a good problem. This is the next problem related to the work and heat transfer basics thermodynamics. Okay, this is also in 2020. I read the question. There is air, it is in system, there is a piston cylinder. This is a very common problem. If you revise the thermodynamics, if you start to study the thermodynamics, such type of problem encounter in front of you. Okay, so always try to think that this type of the question you have to very expert to solving such type of question. Okay, very expert. So what is that? Air act as an ideal gas. Air, it is a content in a frictionless piston cylinder. Frictionless, that means there is no any friction between wall of the cylinder to the piston. Arrangement as shown in figure. Right, I read the question. The atmospheric pressure, it is your 100 kilopascal, and the initial pressure of the air in the cylinder, the initial pressure, that means the pressure it is inside the cylinder is 105 kilopascal. Correct. The area of the piston, the cross-section area of the piston, it is given 300 centimeter square. Please be careful the unit. 300 centimeter square. Now, it is this arrangement. Now you have to supply the heat. Now, heat is now added. The piston, now if you add the heat, the piston is try to move up. The piston moves slowly. This term is very good. There is a very important term, slowly. That means there is a quasi-static pressure. If there is a motion which is a frictionless and motion is a slowly, that process is known as quasi-equilibrium process. Quasi-equilibrium process. And the quasi-equilibrium process is always internal reversible process. Quasi-assisted process, it is always internal reversible process. So this situation, it is when the process 1 to 2 is happening, the process is internal reversible. Okay. What is the generation, entropy generation in the internal reversible process? Anyone please comment in the comment box. What is the entropy generation during the reversible process? Please, anyone? Rahul, Papaji, anyone please? Anyone? What is the entropy generation during the internal reversible process? 0. Okay, 0. There is no any entropy generation. Okay. Now, but this is not related to this question. Okay. Now, heat is supplied to the piston slowly from the initial point until it is reaches to the stops. That means you have to supply the heat and the piston will try to move up and finally it will touch the stops and piston are. And what is the function of the stop? Piston want to move up but the stops doesn't allow to move further. Correct, Papaji, correct. There is a reversible entropy generation is 0. Correct. Now, from the initial point until it reaches the stops. Now, the spring constant K is linear spring. This is the linear spring. Yes, Rahul. Correct, Rahul. Correct. Entropy generation is 0. Correct. Correct. The spring constant of the linear spring, it is there. This is the linear spring. This is also very important term. Linear spring. Okay. Linear spring. And spring constant it is given. Force per mm. Considering the air in the cylinder is in system. That means what is the system? Air, it is a system. Now, work interaction to the process. During this one, what is the work interaction? Please solve this problem. Please try to solve this problem. Now, this problem you have to solve at least 5 methods. Different method you can solve. And that method depends upon your expertise of these questions. Yeah, such type of a question. I will solve this question very basics level. That means very basics. Okay. But it is not like that. You may solve it is by another method also. Please, but I will give you a very proper solution so that you can never be confused during that steps while you have to solve the problem. Okay. So try to solve this problem. Now, my dear, so this is your piston cylinder. Correct. This is your cylinder. This is your cylinder. Okay. Let's suppose this is your stops. Top portion is your stops. Now, this is your piston is there. This is your piston. Initially, this is your piston. Okay. This is your piston is there. Now, in this one, there is a spring is there, beta. There is a spring is there. Okay. Here, there is a spring will attached. That means, this is your stops. Let's suppose this is your stops here. Stops is there. Let's suppose this is your stops. This is your stops. Okay. This is your stops. And there is a spring is there. In this one, there is a spring is there. Correct. There is a spring is there. Okay. This is your spring. Now, my dear, this is our system. This is our system. Okay. This is our system. Air, it is our system. So, this is our system. Air, it is our system. Now, my dear, this is if this is your piston. Okay. Great. There is air is there. Okay. And now you have to supply the heat. So, if you supply the heat, this piston will try to move up. This piston will try to move up. So, this air of a pressure, it is given how much? 1 0.05 kilopascal pressure it is given at point 1. Let's suppose this is our x direction. This is our x direction. So, my dear, what is happening? First, piston will try to move during this displacement. That means up to this displacement. When the piston will move up to this displacement, there is no any resistance. That means what is the resistance is there, but that resistance is constant. So, from this point to this point, the pressure is constant. Why pressure is constant? Why? Because the piston will move against a constant pressure. Piston will move against a constant pressure. What is the constant pressure? Atmospheric pressure is the constant. That means the pressure is given. It is given. Atmospheric pressure 100 kilopascal. It is given. That pressure is constant. So at this point, that means if you measure this one, let's suppose this is your point X. Let's suppose this is your X1 displacement. This is your X2 displacement, and at the stops, let's suppose this is your X3 displacement. This is your displacement. Let's suppose this is your different displacement. Okay, now? Okay. X1 displacement initially, X2 displacement at the just touch the what is that? P is equal to P plus. You can apply. No problem. This at this one there is no any pressure. First draw PV pressure and volume diagram. So if you draw the pressure and volume diagram, beta, this is your pressure and this is your volume diagram. This is your pressure and volume diagram. This is pressure and volume diagram. Now, my dear, the distance it is given here, it is given 8 centimeter. 8 centimeter it is given, and up to a stops, this is also 8 centimeter. Correct? 8 centimeter it is given. Now, what is the answer? 546. Yes, correct. 544. Correct round. Correct. Now, my dear, process 1 to 2. That means this is at point 1. This is at point 2. This is at point 3. Process 1 to 2 is what, beta? What is the process 1 to 2? Isobaric. Yes or not? Why? Why? Because if you move the piston from point 1 to just touch the spring, there is no any resistance, pressure will vary. That means a constant pressure is there. Okay. So isobaric, that means P1 is equal to P2. Correct. Now, process 2 to 3. What is the process 2 to 3? Please tell me, what is the process 2 to 3? Isocoric, yes. Isobaric, okay, correct. Process 2 to 3, when the piston will move, touch here, and now the piston is further try to move up, the spring will try to exert a force. That means, if the piston will try to move up, spring will try to more and more force opposite to the motion of the piston. That means the resistance pressure will increasing continuously while it will move 2 to 3. Correct? Number first, that means if you move from 2 to 3, the resistance pressure is continuously vary. Why? Because now the spring will try to compress. Once the spring try to compress, spring will develop a force opposite to the motion of the piston. That means the resistance pressure will vary. But that resistance pressure will vary directly proportional to the change in volume. Why? Because there is a linear spring. That means 2 to 3, pressure will vary, but that pressure will vary directly proportional to the volume. Why? Because the spring is linear. Correct. That means process 2 to 3, pressure will directly proportional to the volume. Okay, that means linear variation. What is that? Linear variation. Linear variation. Linear variation. Now you have to draw the diagram. So this is point, this is, let's suppose A, and this is point 1. So at this one, let's suppose at this point the pressure is P1, and from P1 to P2 there is a constant pressure. This is your P2, and P1 is equal to P2. So what is the P2? What is the 2 state? State 2 is just touch the stops. State 2 is just touch the stop. Again you have to supply the heat. There is a linear variation up to point 3. So this is your P3. So this is A, this is B, this is C. So this is your, now this total area under the curve is your net work transfer. Why? Because, what is the Rudra? Yes sir, given linear variation, I just calculate the total work done formula. Linear variation, I just calculate the total work done. No. If this linear variation, you just total work done is from A point to C. What said the Rahul? Yes sir, given linear variation, I just calculate the total work done formula. No. Linear variation up to this one. That means this represents, see my dear, I will tell you, there are two areas. This is 1. Let's suppose this is 1. This is 1 and this is 2. So the area 1 represent is what? Area 1 represent is the work transfer due to the displacement of the piston up to just touch the spring. That means in this one there is no any pressure will change. What is the area 2 represents? Area 2 represents the work transfer due to only the compression of the spring and up to the stops. If you add these two, that is the total work transfer. If you add these two, that is your total work transfer. This is very clear. It is not only this one. So many students get confused here. So area 1 represents the displacement of a piston while there is a resistance is constant. Area 2 represents the work transfer when there is a compression. So there is a two step is there. First step, second step. During the first step, there is no any pressure will change. That means the resistance pressure. That means up to this one, pressure is constant. Up to this one, pressure will vary, change. Why the pressure will change have to have? Why? Because spring compression, that means spring will compress downward. That means compression, spring won't force. Now, when the piston will try to move up, spring compression more and more. If spring compression more and more, the resistance force more and more. That means it will shoot up. That means it will like that. Okay, so it will increase, it will not decrease. If there is an expansion is there, this diagram is downward. Clear? Very good. Yes, Rahul. Now you are good. This area of this one plus area of this trapezium. Correct. Plus area of a plus half into Yes. You are right. What you are telling, I understand as a teacher. You are right, Rahul. You are right. Okay. Papaji, your comment, please. So, if you find work 1 to 2, what is that? Pressure into change in volume. What is the volume? VB minus VA. Yes or not? Now, my dear, see this one. What is VB minus VA? P1 you have. What is VB minus VA? VB minus VA, change in volume. So what is the change in volume? Volume is what? Area into displacement. Area into displacement. So area of the piston into displacement is what? In this one, what is the displacement is there? 8 centimeter. That means displacement is x2 minus x1. Yes or not, beta? Yes or not? Yes or not? Now, what is the area of the piston? It is given 300. What is the area of the piston? It is given, beta? Area of the piston, it is given 300 centimeter square. Very good. So 300 centimeter square, that means divided by 10 to the power 4 meter square into this x2 minus x1. So x2 minus x1 is 8 centimeter. So 8 divided by 100. If you calculate this one, this is your 2.4 cross 10 to the power minus 3 meter cube. This is your change in volume. This is your change in volume. Now put here, what is the pressure? What is the pressure? This pressure P1 is what? 105 kilopascal. Kilopascal. So we have to find the work. It is in joule. And joule is what? Joule is what? Newton meter. Newton meter. Joule is what? Newton meter. So Newton it is in. So if you find the Newton, convert this kilopascal into pascal. Why? Because pascal it is Newton per meter square. So here 10 to the power 3 you have to multiply. So this is your P1. Now change in volume, it is your 2.4 cross 10 to the power minus 3. How much it is? This is your 252 joule. This is work 1 to 2. A kilowatt, why you have to put the kilowatt? Watt, Papaji, watt, that means per unit time. We are not any concern with the time. Okay? We are concerning with the joule. See, my dear. This question asking, consider the air. And they are asking the work interaction, not rate of work. Clear? So you have to find always joule. You are wrong. Okay, so 252 joule during this one. So during this one, that means if the piston, that means piston will start to move up. Piston will start to move up and just touch the spring. How much the work is required? 252. How much the work required? 250. Correct. Correct, Papaji. 250. Now, we have to find the work required during the compression of the spring up to the stops. That means work 2 to 3. We have to find the work 2 to 3. Okay. Okay. Now, work 2 to 3. Now, my dear, see this one. What is 2 to 3? This area is trapezium. This area is trapezium, yes or not? That means P2, 23CB. 23CB is the trapezium. So what is the trapezium? What is that means add this minus this volume. So this is your half addition of pressure P2 plus P3 into subtraction of volume VC minus VV. That's it. This is the area of the trapezium, pressure into volume. Now, my dear, what is this one? You have P2, you have P3. Don't bother about that. P3 we have trapezium. Very good. So, what is VC minus V3? VC minus V3 is what, beta? VC minus VV. VV is what? Area of the piston. And VC minus VV. That means X3 minus X2. X3 minus X2. Okay? Area of the piston. So, this is your, all the area it is there, X3 minus X2, 8 is there. So, all this value it is there and this is also there. Now, P2 it is given What is P2? P2, it is your P1. Now, what is P3? How to find P3? That is the very important thing. Yes. Yes. X3 minus X2. Correct. How to find P3, beta? Anyone please? Rahul, Papa, anyone please? How to find P3? Why? Because P2 you have. How to find this pressure? How to find this pressure P3? Please tell me. What is P3 pressure? How to find P3 pressure? Please tell me, anyone, please. See, this all our pressure are equilibrium pressure. So for finding the P3, piston say correct, Papa, correct. I understand what you want to tell from the piston. That means you have to draw the equilibrium diagram, free body diagram of the piston, and we have to find it. Correct. P3. Yes, very good, Rahul, very good. P atmospheric. See, Papa, you are wrong. You have to include the P atmospheric, but here P atmospheric throughout. That means, see my dear, Papa, there is a little bit mistake you have to here. Don't add P atmosphere. Why? Because, see my dear, during the movement from point 1 to 2, there is atmospheric pressure. During the movement 2 to 3, there is atmospheric pressure. So atmospheric pressure is common. Common. Don't count it. Always be there. Don't count it. In the thermodynamics, if there is a constant pressure is there throughout, don't count. Okay? Don't count. Clear? So what is P3? See my dear, from this diagram, what is P3? Please tell me from this diagram. This is very shortcut method is there. Beta. How to find P3? Please see this diagram. P3. You have to find P3. So P3, see, P3 minus P2 is equal to this. Is equal to this deflection. That means P3 minus P2 is equal to what? My dear, this P3 minus P2, who's create this change? Please tell me. This change in pressure, who's responsible to change this change in pressure? The responsible change in pressure is your spring. P3 minus P2 is the change of the pressure during its encounter with the spring. So here P is the pressure, and pressure is equal to what? Force upon area. So what is the force? This pressure, this change in pressure is responsible due to the spring. So spring force K into X divided by area of the piston. That's it. Yes. So what is P3 here? What is P3 here? P3 is equal to P2 plus Kx by area of the piston. Put all this value, beta. Put all this value. That means P3 is equal to P2 plus Kx by area of the piston. Okay. What is P2, beta? P2 same P1 105 kilopascal convert into pascal. So this is P2 plus what is K? Spring constant. Spring constant, it is per spring constant. 1 second, beta. 1 second. Just delete this one. Yes. Spring constant. This spring constant, beta, 12.5 Newton. 12.5 Newton per mm. So convert into meter. So this is your 12.5 Newton per mm cross 10 to the power minus 3 meter. Correct now? 3 plus 3. Newton mm. So minus 10 to the power 3 upper 10 to the power 3. Okay, correct. Into the displacement is x. 8 into 10 to the power minus 2. Why? Because it is in centimeter. So convert it in meter. Divided by area of the piston. Area of the piston is 300. Convert into 10 to the power minus 4. So it is in meter square. Rearrange this one. So this is your 415 divided by 3 cross 10 to the power 3 Pascal. Correct na? So this is your work 2 to 3. Now, so the work total work is equal to what beta? We know that work is the addition. So total work is work from 1 to 2 plus 2 to 3. Work from 1 to 2 path function plus work 2 to 3. Work 1 to 2, it is your P3 is there. No. Put here. So 2 to 3. We have to find 2 to 3 first. So work 2 to 3. Put all these value half. P1 plus P3. P1 it is your 105 cross 10 to the power 3 plus P3 it is your 415 divided by 3 cross 10 to the power 3 plus V3 minus VC minus V3. VC minus V3 is this is your what? Area of the piston. That means 300 cross 10 to the power minus 4 into 8 cross 10 to the power minus 2. Yes or not? Put this value here. This value, put this M value. Let's suppose M. Put here into M. What is the value there? Then you have to calculate how much it is. This is approximately 292 joule. Yes or not? 292 joule. Now you have to add W1 to 2. 252 plus W2 to 3, 292. Add this one. This is your 544 joule. Is there any confusion? Please tell me. No, 29, not wrong. This is your 29. Yes. 0.29 kilojoule. Yes. Correct. 292. Correct. This is okay, beta. Please tell me, is there any confusion or you want to ask anything apart from this one? You can ask. Anyone, please. Beta. If you want to ask anything, please ask. $544. Correct. Clear? This is clear? Rahul, it is clear, beta? It is clear? Please tell me. Is there any problem? Please tell me. All clear. Rahul, all clear, beta? Thank you, Papa. Now, Papa ji, what's your name? Clear. Papa ka ghoda. What's your name, beta? So that I will just name you. Why? Because this name is Papa ka ghoda. It is a little bit difficult to. Jaise Rahul. Rahul, it is good. So Papa ke घोड़े. Is there any name other than that? या फिर पापा के कुछ और? ठीक है? Okay, कोई problem नहीं. Now next problem. See, my dear, this question is a little bit lengthy, but these are the basic question. Money, correct money. Thank you. Very good. I am happy. Okay. So money, this question is very basic question of the power plant, and we always, when you have studied the power plant chapter, that means a steam turbine, if you study the steam turbine, you have to always try to solve this problem. Always. I know that. Either in BTech level, either in practice. So this question is like that one. So my dear, this is the very basic question I am telling you, but little bit calculation. Please be carefully. Okay. So I will just discuss with this one. What is that? See this one. A steam power plant. There is a steam power plants work on which cycle, beta? Please tell me. Rahul, Mani, please tell me, beta. Steam power plant works with which cycle? Anyone? हाँ क्वेश्चन सॉल्व कर देगा. करो. So Steam power plant works on which cycle? Please tell me. Mani, Rahul, steam power plant works on which cycle? Please tell me, beta. Steam power plant works on which cycle? Steam power plant works on which cycle? Rankine cycle. Okay, Rahul, correct. Gas power plant works on which cycle? Please tell me, Rahul. Rankine. Rahul, Papa, gas turbine works on which cycle? Gas turbine works on which cycle? Gas turbine works on which cycle? Please tell me. Gas turbine works on which cycle? Gas turbine cycle works on which cycle? Gas turbine. Gas turbine cycle works, gas turbine power plant works on which cycle? I am telling. Correct. Steam power plant works on a Rankine cycle. And gas power plant works on which cycle? Breton cycle. Which cycle? Breton cycle. Gas power plant works on a Breton cycle. Correct? Now, so this is related to the Rankine cycle. Okay? Now, what is that? Steam power plant, superheated steam at 10 megapascal and 500 degree centigrade, superheated steam, is expanded isentropically in a turbine until it becomes a saturated vapor. That means from the turbine. Yes, Breton cycle. Correct. Correct, Mani. Correct. It expanded isentropically in a turbine until it's become a saturated vapor. Okay. That means steam will expand. Correct. It is then heated at a constant pressure. Reheated. What is the reheater, beta? Okay. You tell me, if you have a reheater, what is the main objective of reheater? Please, anyone? What is the main objective of reheater, beta? Please, anyone? What is the main objective of the reheater? Anyone, please tell me. What is the main objective of the reheater? Please tell me. Anyone, please. Rahul, Papa, yeah, sorry, Mani. Rahul, Mani, what is the purpose of reheater? What is the purpose of reheating, beta? Please tell me. What is the purpose of reheater? What is the main purpose of reheater? What is the main purpose of reheater? Anyone, please tell me. What is the main purpose of reheater? The main purpose of reheater, I give you option. Option number first. Increase during the reheat. Option number first, increase the efficiency. Option number second, increase the rate of heat transfer of the condenser. Right, Rahul. Mani, not dryness fraction decrease, not dryness fraction will improve. Dryness fraction improve. That means dryness fraction will improve. Correct. Increase the dryness fraction and decrease the dryness fraction. What is the meaning of this one? Increase the dryness fraction and decrease the dryness fraction. What is the increase the dryness fraction? That means the what mass of the vapor to the mass of the total mixture. So mass of the vapor will increase. No, dryness fraction will improve. Never you tell that increase or decrease, improvement or not. So dryness fraction will improve. So if we reheat the cycle, if you reheat the Rankine cycle, the dryness fraction improve. What is the advantage to improve the dryness fraction? The advantage, right, Rahul, great. Blade erosion will less. That means life of the turbine will improve. Very good. That is the prime motive. Correct. At a constant pressure to a 500, that means it again reheated at a 500 degree centigrade. Now, the steam is next expanded isentropically to the another turbine until it reaches the condenser pressure of a 20 kilopascal. Okay. Now, my dear, tell me, condenser pressure is positive pressure or negative pressure? Anyone? The condenser in the power plant, the condenser pressure is positive pressure or negative pressure? It is above the atmospheric pressure or below the atmospheric pressure? Anyone, please tell me, Rahul. condenser pressure is above the atmospheric pressure or below the atmospheric pressure? Please think. Okay, the condenser pressure is 20 kilopascal. Now, relevant properties of the steam are given in the following table. The work done by the both turbine. Okay, so we have to find the work done by the both turbine. Work done by the both turbine. So, my dear, this is your reheater. This is your reheater. What is that? See, there is a high pressure turbine. There is a high pressure turbine. Okay. There is a high pressure. So, steam will coming from the boiler and it will expand in the high pressure turbine. Now, total steam will again go to the reheater. That means there is a reheater. Yes, yes. No, condenser pressure is not positive. Condenser pressure is negative. Vacuum pressure is there. Condenser below the atmospheric pressure. Rahul, you are wrong. Mani, you are wrong. Condenser always design the negative pressure. Why? It will detail in the classes. Okay. So, condenser pressure always negative pressure. This is very difficult, very bad concept. Okay. Condenser pressure we are never designed the above atmospheric pressure. It is always vacuum pressure. Okay. So, there is a turbine is there. This is the high pressure turbine. Okay. Now, the steam after expansion from the first turbine, again it will go to the reheater. In that reheater, it will, again we have to supply a heat and again it will go to the high pressure turbine. High pressure turbine, again it is expansion and here is the condenser is there at which the heat will rejected. Now, it will go to the pump and again it will reach the boiler pressure. So, this is the precisely the diagram of reheater. So, what is the amount of the steam will expand from the high pressure turbine? Again you have to reheat and then you have to supply so that the dryness fraction will improve. Okay. Okay, एक बार superheated steam table दिखाना. Okay, correct. Okay, बेटा, I will show you. Yes. Okay, you have to visit this one. Okay. Yes, please, this one. This is your superheated table. This is your superheated table. Pressure, temperature, enthalpy, entropy. Note down, take a snapshot so that you can solve this one. And this is your saturated table. Take a snapshot, beta. I will remove from the board. Please take a snapshot. Okay. Now, so, yes. So, my dear, this is your reheater. Now, in the question it is saying the steam will expand up to the saturated and from here you have to reheat. Okay, na? So, this is 3, this is 4, this is 5, okay, this is 3, this is 4, this is 5 again. So, this is the diagram. This is the diagram. Okay, this is your diagram. Correct? Now, we have to draw the graph of this one. Okay. So, we have to draw the turbine. Now, it is given with us. So, what is that? We have to draw the TS diagram first. We have to draw the TS diagram. Okay. This is temperature and entropy diagram. This is the saturation curve. This is a saturation curve. Okay. Yes. This is the diagram. Correct na? This is your diagram. No, it is not like that. Yes, it is condenser pressure. This is condenser pressure and this is boiler pressure. This is boiler pressure and this is condenser pressure. Steam will in. Again it is expansion. Again it is reheated. Again it is expansion. It is like that. There is pump. Pumping is there. This is your diagram. TS diagram. Okay. This is enter to the first turbine 1, 2, 3, 4, 5, 6. Dryness fraction will check. No. Dryness fraction wrong. Rahul, dryness fraction wrong. Dryness fraction is 979. Dryness fraction 979. Okay. So 2 to 3. This 2 to 3 is a reheat. Now they are asking that, what is that? Turbine work. So this is your pump. This is your pump in. This is the turbine work, high pressure turbine, and this is your low pressure turbine. So 1 to 2 expansion in the high pressure turbine. Rahul, 0.98. Correct. 0.98. Rahul, correct. Okay. So 1 to 2 there is a high pressure turbine expansion. 3 to 4 there is a low pressure turbine expansion. Now my dear, so what is given? State 1 to from state state 1 to 2. From state 1 to 2. What is from state 1 to 2, beta? There is a isentropic expansion. Yes or not? Isentropic expansion. Yes or not? Yes, isentropic. This is the isentropic expansion. State first. What is the state first, beta? State first, 0.1. This is a superheated. Yes or not? Superheated. Yes or not? And this is superheated at which pressure? This is at boiler pressure, and boiler pressure is 10 megapascal. So this is your 10 megapascal. So this point, this is your boiler, this is the point 1 at the same pressure line. 6 to 1 is the same pressure line. So superheated, and this is the pressure at 10 kilopascal, 10 megapascal, higher pressure. Correct? H4, one second. H4 is 25. Correct. Rahul, correct beta. H4 is 2561. Correct. Superheated. So what is the value of H1? So at this point 10 kilopascal, this is your H1. This is your H1. And this is your S1. So H1 it is 3373.6 kilojoule per kg, and S1 is 6.5965. Correct? S1. Now beta, state point 2, it is the saturated. State point 2 is the saturation point. Saturation point. And this is corresponding to 1 megapascal. It is given 1 megapascal. See this one, 1 megapascal saturation. So this is 2 point is saturated point. So 1 megapascal it is superheated is there, saturation is there. So we have to take this table. Saturation, 2 point is saturation. So we have to take this table, not this one. You have to take not this one, okay? So at point 2, clear? So state 2, one second. One second, beta. State 2. Just delete. Yes, state 2. state 2, state 2 is the saturated vapor. Yes or not? Saturated vapor. And this is at pressure 1 megapascal. This is also a reheater pressure. Correct? So what is the value of H2? What is the value of H2? This is your G line. This is your G line. You know that. And this is your F line. This is saturated vapor line and this is saturated liquid line coincide with this point. This is called critical point. Correct? So this is saturated point. So H2 is nothing. It is your Hg. So H2 is equal to Hg. And this Hg you have to find 1 megapascal saturated. Saturated 1 megapascal Hg. Hg. How much it is? 2778.1. Okay. Now, what is S2 here? S2 is Sg. What is Sg? This is your Sg. 6.5965. We have to take a data. Okay. Now, what is H4? Turbine work. Correct, Rahul. Very good. Very good, Rahul. Very good. Now, what is H4 beta? H4 it is your weight region. 4 it is in weight region. So if you find H4, so 4 point it is in weight region. Yes or not? Weight region. So if you find H4, so H4 is equal to HF plus X4 Hg minus HF. And this 4 it is which pressure? This 4 it is a condenser pressure. And what is the pressure of condenser? 20 kilopascal. 20 kilopascal. So at a 20 kilopascal, you have Hg, you have Hg, you have HF. Yes. But so you have Hg, you have HF, you have Hg, you have HF. If you find the dryness fraction, first we have to find H4. How to find H4? So you have to find H4, first find the dryness fraction. How to find the dryness fraction? Equate the entropy. Equate the entropy. That means S3. Why? Because this 3 to 4 is the isentropic. Yani S3 is equal to S4. S3 is equal to S4. And S4 again it is weight region. So this is SF plus X Sg minus SF. Condenser pressure. So from here you can easily find X. Dryness fraction is 0.979. Once you have to find the dryness fraction, put this value, you have to H4. What is the H4 value? 2560.91. This is H4. Now you have to find easily the turbine work. What is the turbine work? Turbine work. W turbine is equal to W high pressure turbine plus W low pressure turbine. High pressure turbine is H1 minus H2. Low pressure turbine is Low pressure turbine is H3 minus H4. H3 minus H4. Put all this value. H1 is 3373.6. H2 is 2778.1. What is H2 beta? This H2, this H2 is nothing. H2 is equal to Hg at 1 megapascal. You have this value. Plus H3, we have know this H3 value. H3 is what? H3 is what beta? H3. H3 is H superheated. Yes, Rahul, correct. H3 is H superheated at 1 megapascal. So, this H3 is equal to H of superheated, but the pressure is 1 megapascal. And H3 is equal to H superheated at 1 megapascal, you have 3478.4. 3478.4. 3478.4 minus, what is H4? H4 just now you have to calculate. This is your H4. H4 it is 25609.91. 2560.91. Calculate all this value. This is 1513 kilojoule per kg. This is per kg. That means this is a specific work out. This is your specific net work output. Net work output from the plant. From this plant. Correct na? Okay, so this session is approximately 1 hour. So now we stop here. Rahul, Mani, you are continuously with me, so I am very thankful to you. But I give you I left one question. If you have any doubt related to this subject, you may post the comment on this comment box, and we try to resolve as much as early as possible. So if you have any confusion regarding this subject, you just post your comment. I will resolve you. Okay, beta? Thank you, Rahul. Thank you, Mani, for your patience. Bye-bye. Take care.